Hello and welcome to section 1.7. In this section we're going to talk about scatter plots and linear models or models of functions. So when we look at this, we're looking at the scatter diagrams down below and we're looking for a line or a curve of best fit. And so if you will look at these graphs, they're asking you to draw a line of best fit for each one of the following and identify the possible trend, and that may describe the trend of the best fit. So if you're looking at this, with it, you can see that these guys are linear functions, and we'll talk about this more, but I could draw a line of best fit that tries to go through as many points as possible and to have the same amount of points above and below the graph. This one, hopefully you could realize that this would be a negative slope of the line of best fit, and we're going to talk about those in just a second, the correlation of these, and then this guy would be a positive, and I'm trying to get as many points as possible. And so both of these guys are linear, one is negative and one is positive. Down here this is a nonlinear graph, and hopefully you could see that this kind of looks like a parabola, and that's a quadratic regression that we might do on this. And so my line would go through, and then here another nonlinear, the line would probably fit something like that, and this would be a cubic regression. And then finally this guy looks like it's starting down here at 0 and going up on forever, and so then we would have something like an exponential regression. And so these are the different lines of best fit for each one of these. It doesn't have to be linear. Typically we talk about linear, but it doesn't necessarily mean that that's the only one. So then we have different correlation and correlation coefficients, and so we have an R value, and the R value relates to how close the graph is for a line to go through every single point. So a strong correlation, the strongest correlation or perfect correlation would be where all the points make a line. And so then if you had a line that went through this, a line of best fit, it would hit every single point, and so you get this R value of 1. And then if it's pretty close, you could have an R value that would hit most points, but not all of them. And so then the closer to 1 you are, the better off you are. And then the more the spread out. And so, but all of these are positive correlation because you have a positive slope. A negative correlation would look like this. This is a fairly strong negative correlation because all the points are going downhill, and then these guys are a little weaker because they're spread out more and there's less points going in one place. And then no correlation, it doesn't matter. No correlation, these correlation coefficients deal with a linear, and so this is a non-linear one, so it would have no correlation to a line. And then this guy is just kind of spread out everywhere, and so there's a 0 correlation. So the closer you are to 0, the less the points you're going to hit with a line. And so now we're going to practice this with our graphing calculators, and so we are going to talk about the New York Stock Exchange from 95 to 2004, and so we will use our regression feature to graph the function and find a linear model for the data. Let T represent 5 for the year 1995. So we're going to go ahead and put 5 in for 1995 instead of typing in all of those numbers. We'll just use 5, 6, 7, and so on. So let me type those in. So now that I've typed in all of those, that's up to 2004, and then I'm going to do the same for the other ones over here. So now that I have all of these entered, I just have to make sure that the bottom rows match up, and I didn't bore you with having watching me type these in as I did this. That's why I paused it and just typed them in. So they're all in there. The shares are in there, and then this. So now we just need to figure out what it looks like on a graph. So I will turn on my stat plot, and I just go to second y equals and turn on the stat plot, L1, L2, we're good. And so now I still don't see it, probably because I'm way up in the hundreds. So I'm going to do a zoom, if I can find it here, a zoom stat, which I believe is number 9 down here. So zoom stat, there are all my points. You can see this is a fairly linear model, and so now it's just a matter of getting the data and see if I can get a line to represent what's going on. So to find the equation of the line of this, we are just going to go through and do what we have done in the past, and you guys have seen this before. We're just going to do a stat, and just like we edited to put in our data, we're going to go over to calculate this time, and we're trying to find a line that's going to model it. And so I will do a linear regression, and a trick that you may or may not know to get the line to show up on your graph, if you go to the vars button and arrow over to yvars and hit enter on function and enter on y1, it will take this line that I'm going to get, the equation of my line, and put it in y1, so that when I graph it, you can see the line going through as many points as possible. So I hit enter, and there we go. There's my linear equation that I get. It looks something like this, and I'll just kind of pull it out for the time being. And so you could see that I'd have a linear model that would be something like y equals a slope of 26.5x plus a y-intercept of 28.97. And so then we get something that looks like this. There's our linear model, and our r squared and our r values are really close to 1. I believe our r value is really close to 1, so that's the one. This model should hit most of our points. And when I go to graph, there's my line, and you can see that by this line that I have here, that the line that's written in red is a fairly good representation of what is going on. So we will practice more of this in class. If you have any questions, please feel free to come and ask.